I'm no tech genius, but I knew if I wanted my business to crush it, I needed a website now. Thankfully, Bluehost made it easy. I customized, optimized, and monetized everything exactly how I wanted with AI. In minutes, my site was up. I couldn't believe it. The search engine tools even helped me get more site visitors. Whatever your passion project is, you can set it up with Bluehost. With their 30-day money-back guarantee, what do you got to lose? Head to Bluehost.com. That's BLUEHOST.com to start now.
So you go to the doctor or you bring your pet to the vet to get your or their prognosis. And they say, minimally invasive. Best words ever when there's a procedure that needs to be done. Now, when I was growing up, my dad taught me about the KISS principle. You've probably heard of it. But my dad, being my dad, changed it a bit. He called it the KISK, K-I-S-K principle, meaning keep it simple, knucklehead. Now, that was a term of endearment in my house, but sometimes he also said, keep it simple, Kyles. Anyways, Stephen Divers, a recognized specialist in zoo and wildlife medicine, joins me. Now get this one from me, endoscopic. Now, that's a big word for me, but it aligns with what my dad taught me, the keep it simple, knucklehead principle. Well, endosurgery is exactly that, a minimally invasive, going to use it, KISK procedure. Stephen is a world-renowned expert in everything endoscopic in the animal world. Now, how does that apply to the animal world? Oh boy, do we really go there today. I just love to nerd out in science, and this episode is everything nerdy for me, from sturgeon to turtles and so much more. Now get this one, the advent of endosurgery for the veterinary world has helped to make great new discoveries and has been hugely impacting for the veterinary world. Now Stephen's an encyclopedia of knowledge and stories, and I truly can't wait for you to meet him. He's going to open your minds to some pretty incredible things. So get ready to nerd out with me. The scope, did you get it, is one you're going to remember for a really long time.
For real, 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 for real. Got a bunch of furry friends and I love them all the same. I'm an animal lover, veterinarian is the name. Let's share some pet stories from heartwarming to strange, losses and gains, from wacky to insane. For real. You're now tuned in to For Real with your host, Mark Kyle.
Hey everybody, and welcome back to the For Real Podcast. Today I've got a really interesting guest. His name is Dr. Stephen Divers. Stephen's doing all kinds of great things, and we're going to get into it. So Stephen, welcome to the show.
Hi, how are you? Good to be here.
Well, I'm great. I'm really excited to get you. I know you're really busy, and you taking the time is really means a lot to me. But what I want to do, Stephen, let's get into your background. Obviously, for people that have clicked into the episode, they know what we're going to get into. But let's get into you. You're a guy from England, and you're here in Georgia. But let's kind of start in England and work our way into Athens, Georgia, and go from there.
Well, I guess if you want to start at the beginning, it all started with my first pet snake when I was about 12, which took about 2 years of convincing my parents to let me have this pet snake. But then my interest in exotic animals just kind of flourished, and my parents were very supportive. I wouldn't be here if it wasn't for them, both biologically and metaphorically. So I owe them everything. But I had, lizards, I had iguanas, I had leopard geckos, I had tortoises, I had fish, we had birds. We had a whole variety of exotic pets. And so it became pretty obvious that that was going to be my career. There was one point, actually, when I think I was about 15, when I was toying with the idea, do I go into veterinary medicine or do I go into human medicine? And my parents sent me on this kind of 2-week, high school sort of vocational course to learn about human medicine. And when I came home, I was like, God, no, I want to be a veterinarian. And my parents were absolutely overjoyed. I think they would have been very disappointed if I got into human medicine. And I think that's the James Herriot factor from the UK, that everyone really kind of loves and respects their veterinarian. So I went to the Royal Veterinary College in London, graduated in 94, then went into private practice, did a lot of exotic pets in the London and around the London area. And came to the United States in 2001 for a faculty position here in zoological medicine, which is the the specialty branch of veterinary medicine that deals with exotic pets, zoo and wildlife animals. And I've been here ever since. And so this is my 24th year, and I'm still loving it.
Well, we've done this. I'm going to make you repeat this. So when we were kind of talking about being on this thing, I thought it was kind of funny. You got a guy from England that's in Georgia. By the way, I love Georgia, so don't misunderstand me. But down in the deep South, going from this proper country, I think is pretty funny.
Well, I find Athens being a sort of a college town. I just love the place here. The music's great. There's great food, but the university really is top notch, and they've really allowed me to pursue my interest in zoological medicine and give me a lot of freedom to pursue these research and wildlife and conservation projects. And so I feel like I'm in a bit of a privileged position here. So I do enjoy it. And like I said, I'm probably going to be here. They'll have to prize me out of my office when I'm dead, probably.
Well, I don't know if you know this. I don't remember if I told you this or not, but I'm in Austin. So it's funny, it's because they're very similar cities. It's a college town, music, good food, and all that. And of course, if you follow the football, Georgia's been beating Texas last year several times. But it's pretty funny. They're become a big rival now. But they're very similar cities, being in a college town and having music. So we're living in two really great places.
Yeah, I agree. And yes, they do love when you say football, I have to be careful because I was born and bred up in, what the rest of the world terms football, or what you would refer to as soccer. But they do love their American football here. And the Georgia Dogs have been very successful the last few years. So they've been doing great.
Well, they've been dominating Texas lately, that's for sure, especially last year in particular. But anyways, we digress, and that's always what I do. So, by the way, have you ever met, there's a guy down in the Keys, his name's, he's a veterinarian, Doug Mader, by any chance?
Doug Mader and I are good friends. We probably talk, I would say on average, maybe once a month. We have shared many a beer at a bar. We've done lecturing together. I remember we lectured in Austria, Vienna, Austria together, and that was memorable because they was celebrating the Austrian veterinary profession. They were celebrating, I think it was their 200th anniversary, and so there was this luxurious ball. And I remember Doug and I were there, and in our tuxedos. But no, I know Doug Mader very well. And we've collaborated on a lot of lecturing and also writing and books. So he actually did the original reptile medicine and surgery textbook, was the editor. And then I took over from him as he retired. I say retired. The guy doesn't know how to retire. He's still busy. But anyway.
Trust me. So small world. I should have told you. He's been on the podcast.
That doesn't surprise me. I think he's everywhere.
Well, he just launched that book, The Vet at Noah's Ark, his book.
Yes,
so we were on there talking that, and of course his wife's a vet as well, and all that kind of stuff too. But yeah. Well, here's the deal. This is part of the thing. Sorry, you guys listening, but the next time you two get together to have beers, I want to meet you guys and sit down and have beers with you guys for sure.
Well, if we're not being recorded, we could probably tell you a few more colorful tales that might be appropriate for broadcasting.
Well, absolutely. So we'll save that for the pub.
Okay.
Let's do that for sure. Okay, so let's get back to you. So you get to Georgia, and can you get into some detail what your specialty is, and then we'll go from there. And I've got all kinds of questions. And actually, there's a specific question I want to ask once we get into this about on human surgery and laparoscopic surgery, a little bit different, but let's get into how you got where you're doing your endoscopic surgery, which is one of your specialties. Let's just follow the path and see where it takes us.
Yeah, well, so that first started actually when I was in private practice in England as a new graduate. I came over to the North American Vet Conference. This was probably 1995, and I took this course on endoscopy and exotic pets, and it was Michael Taylor and Dr. Don Harris, and they were the teachers. And I was amazed. They were putting these endoscopes into these birds, and just what you could see, and you could take safe biopsies. It was incredible. So I phoned up my boss and said, could I have the company credit card? I want to buy the system. And he laughed at me because I was a new graduate.
Hold 1 second for the people that aren't veterinarians, for the listeners. Can you tell people what an endoscope is specifically?
Oh, sure. Okay, so endoscopy, basically, it's Latin for endo, which is inside, and scopian, which is Latin to see. So it's basically seeing inside. So endoscopy is all about using an endoscope and a camera to look inside a body cavity, or inside the ear, or up the nose, and to basically, it's like being miniaturized and going inside the anatomy. So you get to go in, and it's minimally invasive. So you can imagine that if you were doing some sort of endoscopic procedure, a laparoscopic procedure, you can just go in through a keyhole approach rather than actually making a big incision. So endoscopy is all the rage in humans because, let's face it, we don't want to have huge incisions and it's more comfortable.
Right.
And yet I'm thinking to myself, and this is where I got involved, we should be doing this for our animals, and particularly for a lot of exotic animals. Birds are small and fragile, small lizards, tortoises, turtles. And then when you start dealing with wildlife, if you're doing something with wildlife, you want to be able to release them back as soon as you can. And that minimally invasive approach facilitates that rapid recovery and rapid return to normal behavior. So that's where the endoscopy comes in, and that's how I got involved. And so by the time I got to Georgia, I was already sold on it. I was using it routinely, but now I was at the university, so I could actually start to do research. I could actually start to use these techniques for taking samples from clinical cases. I was able to demonstrate that it was safe and it was effective. And by utilizing those techniques for basically exotic pets and zoo animals, so client-owned pets and zoos, then those techniques started to gravitate and started to be in demand for wildlife and for conservation. And so that's kind of how I got into it.
So when you talk about wildlife and conservation, so when you're using a scope to do something, what specifically are you doing to help, in conservation? What are the needs for it? Can you be more specific?
Yeah, sure. So I can give you a couple of examples, actually.
Okay.
So one example, if you think of tortoises, turtles, and terrapins, there's about 300 species, and actually probably about half of them are either threatened or endangered. So this is an endangered group of animals. You've all heard of, endangered sea turtles and freshwater turtles, endangered species of tortoises like the Galapagos tortoises and the Aldabra tortoises, Madagascan radiated tortoise. And so the thing with tortoises is that they have what's called temperature-dependent sex determination. That means that the gender of the offspring is not determined by chromosomes. If your gender or sex is determined by chromosomes, essentially it's a 50-50 toss, right?
Right.
You're either chances are 50% chance you're going to be male, 50% chance you're going to be female. Well, if you undergo temperature-dependent sex determination, then the gender or sex of the offspring is determined by the incubation temperature of the eggs. So you can now see that in a conservation project, if you start incubating your eggs incorrectly and you end up with 100% males, well, that's not going to work out, is it?
Right.
And so one of the techniques that we used endoscopy for was to be able to identify gender in very small tortoises. So if you imagine a Galapagos tortoise, you breed a Galapagos tortoise, you get 50 eggs, you incubate them, they hatch. It may take years before you can determine what's male or what's female, because they look the same as juveniles. You've got to wait till they get to a certain size so you can tell. So if you can only make adjustments to your incubation parameters every 5 to 10 years, you can imagine how long it's going to take you before you get it right.
Right.
Whereas I can endoscope, 6-month-old hatchling tortoises and go, right, we've got 90% female, 10% male. We've got to change the temperatures. And so we were able to make a much more rapid improvements in incubation parameters in order to create a more even sex ratio, which is important for them releasing or conservation projects, either in situ or Head Start programs in zoos. And so that's one example where endoscopy has proven invaluable.
So let me ask you a question. So when you talk about temperature, so if it's warmer, it's a male or female, and that. So how do you do that? how do you control that temperature in the incubation process?
Well, so what they do, they basically remove the eggs from the nest, put them into artificial incubators, and they set the thermostat.
Oh,
And so you know we've done the same thing. You can artificially incubate bird eggs, and you can artificially incubate reptile eggs.
huh.
Now, birds is genetic, but with the reptiles, the tortoises and the turtles, and some lizards, it's temperature dependent. And so that's why you've got to be very careful and make sure you get it correct. And I remember the first project I got involved with actually that was involving endangered Asian box turtles. And it was a PhD project from New York. And they asked me, could I identify gender in these 60, I think it was 58 or 60 hatchlings. They were about the size of a quarter. They were about 10, 15 grams in weight. So just imagine, very, very small. And so they sent these animals, brought these animals down, and they thought, we're pretty certain we got 50-50 mix. And I endoscoped them, and I think out of 60 animals, I think there was 58 females and 2 males. And I was like, no, we haven't quite got it correct.
Right.
And I thought, wow, this is incredible. And then it started happening that I got breeders wanting me to be able to identify gender. And so that's how it.
Wow, this is fascinating.
And now I think we've up to about 14 or 15 species. And I think one of the coolest ones I did was about a year or two back. I went to the island of Rodrigues, which is a small island part of Mauritius. In fact, if you Google Rodrigues, you have to zoom out at least 3 times on Google Maps before you see any kind of other land mass. It's kind of
Wow.
it's kind of a few hours east of Madagascar, and so I went there and we endoscoped like 300 tortoises to help them with their incubation parameters and to ensure appropriate sex ratios. So that's one example.
So one of the things I did, do you know who, by the way, another name, Brad Nahill? He's a sea turtle guy.
I've heard his name. Yes, I'm not as friendly with him as I am with Doug.
Well, yeah, you haven't been in a pub with him, in other words.
No, exactly.
So one of the things that he talked about was climate change. Is that part of the issue right now too, as well?
Well, that's obviously a concern, is that
Uh-huh.
for a species that has temperature-dependent sex determination, if the temperatures warm up, are we going to end up with an increasing number in the case of
Right.
tortoises, and in the case of turtles, an increasing number of females? Now, fortunately, we don't need as many males as we need females, and so maybe it won't be as problematic. But that is certainly a concern that you're going to start to see some ecological changes as a result of some of those global climate changes.
So let's stay on your topic. By the way, I apologize. I have to do this almost everything. I start going all different weird directions. I apologize on that part.
That's all right. And we'll just meander as we go. I have no problem with that.
Yeah, well, that's usually what happens to me after I've been in the pub for a while too. So, anyways, now my rugby's coming out. But anyways, I want to kind of go into you because you've done a lot in Galapagos.
Yes.
So let's talk about your specialty in the Galapagos. And by the way, what I love about the Galapagos, and a lot of people don't know that, it's part of Ecuador, which makes Ecuador the most biodiverse country in the world, by the way. So can we talk about that? Because I think that's fascinating as well.
Well, so yeah, this is definitely one of the highlights. I've been back on 2 occasions over the last sort of 12 years, I guess. But the Galapagos tortoises, they used to number, more than 250,000. And unfortunately, due to a variety of problems, back in the day, hunting tortoises for meat, agricultural clearance, introduction of vermin, particularly goats, was causing a problem. And you may have heard, do you remember Lonesome George?
Sure.
You may remember Lonesome George. So Lonesome George was the last remaining tortoise from the island of Pinta, which is the most northern island of Galapagos. And they did a survey in like the early 70s, and they were amazed, devastated to find they found one tortoise, because the island had basically been overrun by goats, which were out competing the large herbivorous tortoises.
Mm-hmm.
So they took him off the island, and then they tried to eradicate the goats from the island. And it took them a couple of decades, actually. It took them a while, about 30 years. But eventually they eradicated all the goats from the island. And they wanted to, having removed all the goats, now there was no herbivores on the island. So now everything's overgrowing, right? You don't have any herbivores keeping the ecosystem in check. And so I got contacted. I had nothing to do with that previous part. At this point, I got contacted and they said, hey, divers, we've got like 50 giant tortoises, which are basically in a zoo environment on Santa Cruz. And these animals are basically hybrid. Before we knew the genetic diversity and the genetic differences between the islands, we were just breeding giant tortoises, from different sources. So from an ecological perspective, they're genetically poor.
Right.
But they had 50 of these subadult to adult giant tortoises. And they wondered, could we release them onto the island of Pinta? So that they could engineer this kind of ecological recovery, do the job that they're supposed to do.
Right.
And I was, and the reason they wanted me involved is because they didn't want to release these animals with the ability to breed. Because if they then reintroduced high genetic value Pinta tortoises in the future, they didn't want them interbreeding with this low genetic stock of crossbred tortoises that have been, bred in the 70s and 80s. And so they said, can you endoscopically sterilize these animals? And so we developed the technique for endoscopic sterilization of females by working with people's pet tortoises and turtles, because reproductive disease is a big problem in pets. And so we developed the technique. And so at the time I wasn't sure, but I said yes, because I could smell a free trip to the Galapagos. So I got together a team. There was me, a guy called Joe Flanagan, who's one of the vets at the Houston Zoo, Sam Rivera, who's one of the senior vets at Zoo Atlanta. I took one of my house officers, Dr. Emmy Canafo, the first time, Dr. Kelsey Trump the second time, and one of my technicians, Nia Chow. So I put this surgical team together and got support from Carl Storz to loan us equipment, which is required in the field. And we basically trundled down to the Galapagos, and over about an 8-day period, we sterilized, I think it was about 45 male and female tortoises. So we sterilized them, and then I think it was about 6 months later, they went through a full recovery and a pre-release check. And then they were released onto the island. And so that was an incredible thought, that you had these animals that were basically, stuck in a zoo environment, had been sterilized, and now were roaming free on the island of Pinta and, trying to, and are doing a successful job of engineering a ecological recovery for that island. And so that worked out really well. But I have to tell you, I know you wanted to say something, but I just wanted, before I forget, here's the thing that still to this day makes the hairs on the back of my neck stand up. We were there doing this back in, I think it was around 2011, I think it was. Anyway, while we were there, they were celebrating the 200th anniversary of the publication of The Origin of the Species.
Oh, wow.
Right. So there's a lot of events going on. There's a lot of parties and people, they had these VIPs that were being toured around the facility and coming and seeing us work on these giant tortoises. And then I'm at one of these get-togethers, and this gentleman comes up to me and he's very interested and sort of inquiring about what we're doing and why. And then it transpires that he was Charles Darwin's great-great-grandson.
Oh, my God. I've got goosebumps on my arm right now. That's amazing.
As a Brit, following Charles Darwin to the Galapagos Islands and dealing with giant tortoises, it doesn't get any better than that.
Well, and what you're doing has something to do with origin, too, when you're sterilizing. That's crazy.
Well, exactly. So that's often the thing that people don't understand. Hang on, you've got endangered tortoises and you're sterilizing them. We're sterilizing these ones because they're low genetic potential, but we want them to go out in the wild and do their thing and engineer the recovery. So when we actually do have high genetic Pinta tortoises, they can go into a more pristine environment. So that's the idea.
God, that's so cool.
Yeah, it was very cool. I have to say, that's definitely one of the highlights of my career, was getting involved in that kind of project. And actually not just doing that work, but being able to take down a team from Georgia down there to do those procedures. In fact, we went back again just a couple of years ago and did another group of animals. And there may be more, in the future. But certainly it was just, one of those career highs for sure.
It reminds me, meeting anybody that is descendant of somebody so important, and this is completely has nothing to do with what we're talking about, but I had the opportunity to meet Gandhi's grandson. He'd written a children's book. I've written some children's book, and my editor happened to invite me to meet him. And just the opportunity just to kind of let it rub off on you a little bit is kind of a really cool thing.
Well, and actually, so I can't remember his name, unfortunately. I think he passed away a couple of years ago, but he was an architect, so he wasn't anything involved in zoology or biology. He was an architect, but he still was a very prominent figure and was still so interested in his great-great-grandfather's work. But it was, like you say, you meet these people and all of a sudden it brings history crashing towards you. It's kind of an incredible feeling.
Well, and it's a bookmark in your life, right? When you get to meet somebody that really had some historically to their family, and just to meet them, for me, it was a bookmark for my life, just to remember that, a highlight.
And now let me ask you this. Did you realize that at the time?
Oh, I did.
Okay, because I also think that, and I did too, but it's interesting, only with perspective that you look back and you go, that wasn't just a great day. That was one of the greatest days of my life, and so I treasure those memories and the photographs that I have of that trip.
I have a picture of I invited a good friend of mine with his two younger daughters to be there. I have a photo of him with them, and he wrote this book. It's a children's book called My Grandfather Gandhi or Grandfather Gandhi, and it's a really cool story. It's literally about Gandhi, but it's this beautiful, illustrated book that was there. But just there, and he played the sitar when I was there. It was so cool. It was just really, really one of those things. Again, there's my animal story, but anyways, let's get back on track there. So you were there and you were working with them. So like the question I was going to ask, so when you introduced them to the island and they're sterilized, what was the ecological impact? They were replacing what the goats were doing? I mean,
yeah, so basically, these giant tortoises, these are 400-kilo bulldozers, right? And so what they do is they're important for creating grassy avenues through the forest, right? So they're also important for seed dispersal because they eat plants and fruits and then they defecate the seeds out further away. So they have important ecological functions. And if you look at some of the pictures of the island, where they have they had a technique called exclusion fencing, where you have an area, you put up fencing to exclude a certain animal, in this case goats, and you saw all the lush vegetation, and outside the fence where the goats were, it was literally like desert. I mean, it was just incredibly, destroyed. And it's interesting, 58,000 goats all stems from the fact that back in the 18th century, some seafarers, probably British, will take the blame for it. But anyway, they released, a dozen goats on the island with the idea that, well, they'll breed. And then when we come back past this way, we can kill a few. We've got fresh meat.
Yeah.
Well, unfortunately, great ideas of mice and men, it seems. But that was a bit of a disaster for the tortoises. But hopefully they're now, I think they're making great inroads. The population's coming back in various islands, and I think they're doing a great job. Ecuador's doing a great job, I think, at trying to preserve the Galapagos. And best of luck to them.
So these were sterilized. So, and how many were put on the island? Did you say 60?
Yeah, I think it was 40. Actually, I've got the numbers here. I think it was 45 that was sent initially. And I think we did another group of another 30. Because these animals get large, they can have quite an impact. And they actually had ecologists on the island. These ecologists were on the island and they're tracking these animals. And so they know they're doing what they should be doing. They're seeing the positive benefits and the effects. And so there's the ecological perspective. But then as a veterinarian who's primarily concerned also with animal welfare,
right?
Imagine the fact that these animals that were, incarcerated into these captive conditions, which obviously were pretty restricted, were now able to freely roam this island. I just feel like from an individual perspective,
right,
that would be such a better situation, for them to be in.
Well, you look at micro and macro, right? So if you hover above and you say, oh my God, these guys are so free now and they get to do that. So how long do they live? They live for a long, long time, right?
Yeah, I mean, it becomes quite controversial, but I mean, they can certainly exceed 100, 150 years. I'm not quite sure what the longest one is. The trouble is that records somewhat become a bit,
Sure.
blurred, but they are certainly long-lived animals. It can take them, 10, 20 years to get sexual maturity. Yeah, these animals are very long-lived for sure.
And so they'll, so if you've got 100, let's say, on there now, they'll be there for a long time anyway. So you don't have to worry about adding more. And they've taken replacement. They've replaced the goats and bringing back I guess, the purer sense of the tortoises that were there.
Yeah, exactly. That's the whole concept,
Uh-huh.
and it's just it does two things. You're basically killing two birds with one stone, if you like. You're helping the ecological island recover,
Yeah.
and you're helping the welfare of these tortoises that were, poor genetic value. So it works out all around, really.
That's so cool.
For real, 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 for real.
And we'll be right back. We are supported by PrepVet, providing stem cell therapy for pets.
As a pet lover, did you know your pet can benefit from the incredible healing power of stem cell therapy? Prep Therapy offers a groundbreaking solution taken right from your pet's own blood. Say goodbye to joint pain, arthritis, kidney and liver conditions, and more. They'll experience faster recovery, increased vitality, and extended quality of life without the need for surgery or harmful drugs. Put the wag back in their tail and discover Prep Therapy today at prepvet.com. Save 10% with promo code FurRealPodcast, covered by most pet insurance.
So let's talk some of the other endoscopic things that you've done and different animals and that too. Is it mainly tortoises there in Ecuador is where you were working on there?
Yes, it was mainly the tortoises on the Galapagos. We also did sexing for their, the baby Galapagos tortoises, so we could make sure the incubation parameters were good. So that was another aspect to it.
Uh-huh.
Then we did the sexing also in Mauritius and Rodrigues. That's probably the main thing from a conservation perspective. We use a lot of endoscopy because you can imagine a tortoise is essentially a bony box.
Right.
It's pretty tough to get access internally for disease diagnosis.
Sure.
We use a lot of advanced imaging like CTs and ultrasound, but the endoscope gives us access inside, so it's much easier for me to diagnose kidney disease or liver disease with the use of endoscopy because I can go in through a tiny hole, take a biopsy, get a diagnosis, and the animal literally has a single suture when it wakes up from surgery.
Right.
So that's the other technique that we use it for, diagnosing disease. From another conservation project would probably completely changing tack would be sturgeon. So, sturgeon, there's a number of endangered species of sturgeon. A lot of the sturgeon populations that we have on the eastern seaboard of the United States have become disadvantaged because of the way we've managed our rivers, dams and, the things that block the migration of these fish, because these fish come from sea into fresh water to spawn. And so if they can't get access to those spawning grounds, they can't breed. And so the populations decline. And so I was asked to look into pallid sturgeon, which is an endangered species. And so one of the things that you need to identify is their spawning grounds, because if you can identify where an endangered species is breeding, then you target your conservation efforts on those locations, right? Because they're obviously critical. And so what they wanted to do, they said, could you identify the gender of these fish and place a sonic transmitter? So we were going with an endoscope and identify the females, because the females are the ones we wanted to know where they were laying their eggs,
right,
where they were spawning. So we identified the females with an endoscope, and then we would place these sonic transmitters, because you can imagine a fish doesn't do well with a radio antenna sticking out of its back. And so you have to use a sonic transmitter. So a sonic transmitter, imagine it looks like a black torpedo and it's probably about 2 inches long, and it's probably about half an inch wide. And so you sterilize them. They've got their own internal circuitry and battery that lasts for a couple of years. We would surgically insert them into females, close them up, and then they get released. And then all up the Mississippi River, they have these sonar buoys. And every time a fish goes past a sonar buoy, it triggers a marker because of the sonic transmitter displays, its position. So now they can monitor these fish moving up and down the river and identify where the spawning grounds are. So that's another example of using the endoscope. And then the other topic we did with endangered sturgeon is looking at environmental contaminants. And so we actually developed an endoscopic forceps that we could use to take large liver biopsies for toxicological analysis. Because guess what? What's an environmental pollutant for animals is an environmental pollutant for people as well, right? We can't separate ourselves. It's this one health. And so there's wildlife health, human health, and ecosystem health, and it's all integrated.
Sure.
And so that was another thing that we were able to get biopsies from these fish so they could evaluate those kind of things. And the beauty was that the fish were live at the end of it, whereas previously you would have to sacrifice animals. You'd actually have to necropsy to take tissue samples, and you wouldn't have a live fish to put back. Whereas with the endoscopic techniques, it's minimally invasive. Live fish at the end of it gets released and go about their day.
Here, quick question. So both on the tortoise and the sturgeon, and I want to ask some more questions about the sturgeon. Did you guys have to change your anesthesia, like come up with a different formula that would keep them alive afterwards and all that kind of stuff?
Yeah, so that's a really good question. So for instance,
A rare moment.
No, it's a good question. So if you imagine we're working on the Galapagos island, and there's no compressed gas. So we can't get compressed oxygen. So we can't use inhalant. So normally we would use inhalant gas like isoflurane or sevoflurane. Just like if a person went into hospital and they have inhalant gas, we were unable to get that on the island. So we had to change our approach. So rather than using gas for anesthesia, we had to use injectable drugs. And so we were using a combination of ketamine and medetomidine, which is basically two sedative anesthetic combinations. We would use those. What was really interesting is because no one had done this before, we would use these injectable drugs, but we were still finding that we needed, greater analgesia. And so we came up with the technique of what we call intrathecal anesthesia.
I know intrathecal very well.
Okay.
Through the back.
Okay, so we thought, well, why don't we try that? And we tried intrathecal anesthesia on these tortoises, and it worked like a dream. And in fact, it was so good, we published the technique when we got back to the US, published it in a veterinary journal. Subsequent to that, other people have looked into it and have published. And so now it's become an established anesthetic option.
So for you guys that are listening, intrathecal is similar to like a spinal tap. So it's going into the spinal cord is what you're doing, right?
Well, it's going into the spinal canal. You're trying to avoid the spinal cord.
Yeah, exactly.
It's probably the most common. It's probably equivalent to. So you would think of an epidural.
Right. Exactly.
But reptiles, they don't have a subarachnoid space. They don't have the same anatomy. So you can't use the term epidural.
Right.
So we use the term intrathecal. But essentially, it's spinal anesthesia.
Right. So we, and again, I'm going to go when we were talking about stem cells earlier for what I do. When we're treating neural disorders, we do, a lot of vets won't do it because they learn it in school and they never do it again. But because it's not that hard, but it's scary. So we do for like degenerative myelopathy, which is ALS basically in humans, is that they'll do an intrathecal injection of stem cells, doing the same idea.
And we found that was great, worked so well. So that was one example of how we had to modify. Now for the fish, what they would do is they would catch the fish on baited lines, and then we would anesthetize them. So in the same way we just talked about, gas.
Right.
And in humans, if you're anesthetized, you're going to have anesthetic gas circulating in oxygen.
Right.
And so your anesthetic machine is basically a gas circulating, an oxygen circulating machine. Well, for fish, we use essentially the same kind of idea, but we use water rather than oxygen.
Oh.
And so we had this specifically designed fish anesthesia machine and surgery table. So the fish would be in a large container. It would put into a large container with anesthetic solution.
Oh, wow.
It would go to sleep. We would lift it up and put it onto this surgery table, and then I would put a tube in its mouth. And so basically, there was a reservoir under the table which would pump anesthetic water up to the table, into the mouth of the fish, over its gills, and then drain through this fenestrated table back into the reservoir. So it was a water circulating anesthesia machine.
So they're getting the oxygen and anesthesia through the water like they normally do in their own environment. That's so interesting.
Right. And so that's kind of the way. So it's interesting, when you talk initially, you talked about my specialty. So
by the way, wait a minute, let's hold on there again. So I'm reading your bio and something, and your specialty is like two paragraphs long.
So that's the thing, right? So imagine, there's like 10,000 species of reptiles. There's like 10,000 species of birds. There's like 6,000 species of mammals. There's 20,000 species of fish. So basically anything that's not a dog, cat, horse, cow, pig, or chicken falls into the category of zoological medicine or non-domesticated animal medicine. So that's me. So if you like, I'm supposed to be a specialist on tens of thousands of species. And so our approach to this is just basic principles. We take the principles of anesthesia that we know from humans and domestic animals, and then we translate them and use them in free-ranging pallid sturgeon or in Galapagos tortoises. And so that's kind of the approach.
Hey, can we on sturgeon? I'm curious, and I know a little bit more than some, but a lot less than most. But I know they're prehistoric. But what are they in size? I know they can be really big. But what's like with the ones you were working with in the Mississippi region? How big are they?
The ones, you're right. There are some species of sturgeon that can get sort of like 8 feet long, 6 to 8 feet long.
Right.
Most of the sturgeon we were dealing with were probably in the region of, I would say, 2 to 3 feet in length, probably up to
really big,
up to a meter in length. So these were pretty big. But we use the same techniques, endoscopic techniques. I've used them in goldfish, people's pet goldfish.
Wow.
And so the whole thing is scaled. So endoscopy, the smallest animals I've used endoscopy in are probably 10-gram turtles or fish. And then the biggest animals, there are veterinarians who have used endoscopy to do castration in African elephants. So you're going all the way up to
wow.
4, 5, 6 tons. And they're using the same camera light system. The only thing that's different is the terminal equipment, which is obviously geared towards the patient size. So, if I'm dealing with things that are very small, I'm using a 1.9 millimeter endoscope. If you were working inside, an elephant, it's probably a 25 millimeter diameter endoscope. So it's just varied depending on the size of the animal.
Okay, so I've got a question. So my dad had a disorder, and he's passed now, but he had hemochromatosis. Are you familiar with that at all?
Yes. Yeah, we see that in a variety of birds specifically.
Well, that's why I wanted to ask you. So he ended up having a bleeding ulcer to start with. And so when they scoped him, they went down, he had the esophageal varices, and then he ended up passing away pretty a short period after time when this happened. And it's my theory that the varices were esophageal varices, for guys listening, is enlarged veins basically in your esophagus. They're way bigger than they should because something's not functioning correctly. I'm hoping I'm saying that right.
Yeah, you're correct.
And so I think what happened is when they went down the scope, I think they probably ruptured a couple of the veins, and he was not healthy to begin with, and I think his system just started shutting down. So you see that? Do you see those as well? Is that because their liver or something else is not functioning well? Is that what the deal is?
Yeah. So no, we see quite a lot of hepatic or liver disease disease
Sure, liver disease. Yeah.
in birds and reptiles. And unlike humans, in humans, it's one species. And so we've got such good detailed information, and such good testing that there's so much you can do on a blood test.
Right.
But, when it comes to animals, these tests have never been sort of really developed for those species. We use them; they might give us an indication, but we don't have the degree of accuracy or faith that we can have in them.
Right.
And so, really, the best way to make a disease diagnosis of, say, liver disease is to be able to get inside and get a small piece of that liver and get a biopsy. And endoscope gives us the ability to do that. And so, yes, for instance, in certain species like hornbills, toucans, we see quite a bit of hemochromatosis. It's usually related to diet because they're being fed a different diet than they would in the wild, and they have a lot more iron absorption in captivity. But we can identify that on a liver biopsy fairly straightforward, whereas trying to diagnose it on a blood test can be much more complicated. And I certainly think that because of the skills we have here and the equipment we have here at the University of Georgia, we do a lot of endoscopy and we get a lot of cases referred. I mean, I've had people send their animals from California. I think the furthest one I had was someone sent me a turtle from Alaska, from Anchorage, Alaska. So, I think because we have a reputation and not just for clinical excellence, but we actually run a course here. We teach veterinarians from around the world to do these techniques at the university every year.
Right.
And so, we train about 16 vets that come in. So we teach them these techniques so they can go back to their countries and then employ them where they are.
Do you coordinate with people in the human side on endoscopies for them I'm sure you're refining your technique all the time, or are they coming back there and talking to you and say, what are you doing here? And then they transfers over to the human side?
It's actually more the other way round. If I'm looking, I'm looking for a piece of equipment to be able to go into an endangered freshwater mussel and take a biopsy. And I'm thinking, okay, this is kind of what I need. Well, pretty much everything, there's so much development and things are developed in humans for very precise and very specific indications. And whereas I need to use something that's got a sort of pluripotentiality that I can use across a whole spectrum of species and conditions.
Right.
I'll give you an example. The primary endoscope that we use for most of our birds and reptiles and fish, for most of the exotic animals that are less than about, say, 3 to 5 kilos, so about less than about 10 pounds.
Right.
We use what's called a 2.7 telescope in an operating sheath or in an integrated sheath. I'll give you one guess what that equipment was used for or designed for in humans. Any ideas?
I'm going to go for it's going to be something. I don't know. Tell me. I have an idea, but I don't want to say.
Okay. All right. Well, it probably can't be worse than the actual truth. This endoscope was actually developed to perform cystoscopy in female pediatrics.
Wow.
So this was a scope that was developed specifically to be able to go into the bladder of young girls who had bladder issues or urinary issues. That's what it was designed for.
Well, let me tell you, I thought it was going to be a penal thing too. So I was kind of there.
You were kind of there.
Yeah.
But the point is, that was developed. So now, if you get all the equipment that's been made in humans for all these different types, you can pretty much find something that's going to fit with what you're trying to do in veterinary medicine. So I tend to, and I'll give you another good example. I was always trying to develop a technique for doing laparoscopy.
Sure.
That multiple entry endoscopy that you see in people and in larger animals. I wanted to do it in smaller exotic species, like in birds and small reptiles. Well, the standard laparoscopic equipment was 5 millimeter.
Right.
And that's too big to go into a 400-gram bird or a 500-gram bird. I think it was in 2001 or 2003, early 2000s, I saw a new catalog that came out from Karl Storz Endoscopy, and it was pediatric laparoscopy. They developed a 3 millimeter system for doing laparoscopy in babies, both in utero and post-birth.
In utero. Wow.
Yeah, they're doing some of this stuff in utero. And this 3 millimeter equipment, it was like, eureka, this is what I've been waiting for, you know?
So I got a question for you real quick. Do you know Harry Rich by any chance?
I don't.
Okay, Harry Rich he's the father of laparoscopic surgery. He did, especially in female anatomy. He was the very first, and everybody that in the laparoscopic world, in the human side, and Harry's a good friend of mine, but he did the very first hysterectomy via laparoscopic surgery. He's the father of it.
Okay, well, so basically, I now do the same thing in rabbits, thanks to him and this 3 millimeter equipment.
I need to put you two together because I guarantee you, when you're looking size and different things, you guys could talk together. You probably, and by the way, he'd be in the pub with us. He's that guy. You would love him.
No, that sounds perfect. I do sometimes talk to human surgeons to get their perspectives. And it's interesting because they are so focused. You know, they literally do one procedure. And, you know, if it's a slightly different structure, or if it's a slightly different age class, it's a different surgeon. You know, it's like it's so hyper focused. And I've watched human surgeons. I remember I had a human surgeon come in to help me to remove a thyroid mass from a monkey. And I thought, well, this is a monkey. Human surgeon's going to know the anatomy and be better. And I watched this human surgeon operate, and it was just, it was like art in motion. It was just so impressive.
Magicians are crazy.
Oh, it's just incredible. I'm sure most people don't get to see that or don't get to appreciate that. But the training that these surgeons go through is just incredible. Whereas me, I'm more like breadth rather than hyper focus. You know, I guess the only thing I do is endoscopy, but I do it on so many different species in so many different situations that, you know, I still have to be, you know, focused on, right, what's my anatomy for this case? You know, I can't remember everything, so I have to constantly review.
Well, you know, I went in surgery. What's amazing, these guys, laparoscopic surgeons, I'm probably similar. Their shoulders are so strong because they're having to use that. It's amazing watching it. I sat in a surgery in Columbia, New York, with him when he was removing a fibroid, and it was the most wild thing I've ever seen. It was just crazy.
Right?
Yeah, it's wild.
Yeah.
Okay, I've got two more questions for you because I know you're busy, so I don't want to take too much of your time. So when you're doing, are you looking for, like, I know with all the plastic in the world and that too, are you looking at that in some of these animals and seeing, especially the ones that are in the water, the aquatic animals, are you seeing a lot of that? Is that something that you're doing as well, looking to see if they're swallowing plastic and all kinds of crazy such stuff?
So plastics is not my particular interest, but there are people at the University of Georgia that have been looking into that. Shout out to one of the senior professors here would be Dr. Branson Ritchie, and he's been looking at these plastic issues and trying to come up with modern and new approaches to materials.
Right.
So I haven't looked at that specifically, but one thing I have seen which came about is when we were biopsying these fish and trying to determine males and females, we got sort of, 47-48% females. We got sort of 47-48% males, and we were getting 5% intersex. So we were getting 5% of these fish that were having mixed gender, mixed sex. And I was talking to a human researcher, and what was interesting is they were seeing a similar increase in gender or reproductive issues, either associated with intersex, hermaphrodite, or hypospadia, reduction in normal reproductive anatomy in people. And so it was just eye-opening that, again, we think of ourselves as being separate from the natural world, but these pollution, and we think this was actually due to endocrine disruptors and certain pollutants in the water. And, we drink the same water. And so it's, in fact, we're probably the source of the endocrine disruptors, to be honest, anyway. But it just goes to show you that we can't live in a vacuum. We have to be cognizant and we have to be aware of our environment, of our wildlife. If we value our own health, we have to think about ecosystem health, and we have to think about wildlife health as well.
Yeah, I mean, well, don't go. I got to stay away from politics. Anyway,
no, you're right. Let's not go there.
I so want to go there. Back to your muscle. So the reason why you were doing that thing with the muscle, was that for ecological and environmental things?
Yeah. So it was a researcher that approached me, who said, I'm working with endangered species of mussel, and I want to get samples to look at toxicological, changes and pollutants. But these are endangered. I don't want to kill a mussel to get the sample.
Right.
So we worked with them, and we came up with a mechanism by which we could anesthetize the mussel and then go in with an endoscope and take a biopsy from the tissue that they could then use for ecological and have a live mussel at the end of it. And so for me, I like to, I'm not a genius. A genius is someone that can come up with something completely original and unique. I'm kind of more of a problem solver. People come to me and say, this is a problem. How do I get a sample of the kidney from this species? How do I get a sample of the liver from this species? How can I get the reproductive tract out of this animal? And so then I just apply endoscopic techniques to kind of come up with a solution for that. And it's amazing to me. I never come up with these projects. People approach me, and then I'm like, yeah, that sounds like great fun. I'd like to be involved with that. But I don't come up with this stuff myself. There are other great minds that kind of work on this stuff, and I just get sort of slotted in, further down the line.
Yeah, but I think it's people like yourself that actually advance the science. That's the it's nice for somebody to come up with an idea, but somebody to take that idea and actually create something that actually makes it better is ultimately the bigger deal anyways, I think.
Well, I think that's the advantage of being in a university, right? The university values that. When I was in private practice, I never had the mechanism or the time or the financial resources or the equipment resources to answer those questions, which is why I said, when I left private practice and came to the university, my head was bursting with things that I wanted to do, and they gave me the opportunity to do it. And so I think to me, it's like everything had to align. In fact, it's really by luck and by chance. The reason when I came to the University of Georgia, I remember it's 2001, there was a senior professor, Clarence Rawlings, he's retired now. He had just really started to get into endoscopy, and he was pursuing a large grant to get equipment into the university to use for teaching and research and development. And he just let me, as a very junior assistant professor, he let me piggyback on his coattails, and he carried me for the first couple of years until I could find my feet and start working in my own research areas. And so a lot of it is luck, that you have to just count yourself lucky if things come along at the right time. You have to grab those opportunities when they arise.
Well, luck is also being in the right place at one time and being aware that you actually have that luck too, I think.
Well, you don't realize you don't realize until you look back. It's like you just have to grasp every opportunity you can, and then you might look back in 5 years and go, good grief, I'm so pleased that I agreed to meet with that individual, because that produced this whole avenue of work over the next 5 years. In fact, here's a good example. When we first did the Galapagos and we tried to do castrations in giant tortoises, the first one I did, we were unsuccessful. And that then led to 5 years of research and development to try and come up with a technique of endoscopic castration for these giant tortoises, for tortoises in general. And so it's amazing how, a lot of things that come along that are either adverse events or don't work out, failures, basically, right? For want of a better word, you have these failures, and they can often be the catalyst, I think, to then pursuing something with real meaning behind it. And I think, I've learned that failure is not something to shy away from. It's something to embrace.
Well, I use this all the time, because I'm a big sports person. Is I always tell people you've got to learn, you got to lose to learn how to win.
Right, I agree.
I really believe that.
Yeah, no, I agree, and I think it's unfortunate, but I do see sometimes in younger generations are fixated on being a winner or winning and being successful, and I think you don't understand the value of that if you haven't had to work through failure to get there. So I think it is key, it is important. And there's nothing more humbling than medicine, because there is nothing more humbling than Mother Nature, who's, trying to fight against you sometimes.
It's so fascinating. To me, it's just amazing. So what else can we talk about? I know, we were on a window of time. What else do you think that we should bring that the listeners may be really interested in? And
well, okay, let me give you one other example.
Okay.
And this is a cool example as well. So I mentioned before about sturgeon being extubated from the eastern seaboard. Well, I got a contact a few years ago now, from the U.S. Fish and Wildlife Service. They had, high genetic, high value, endangered sturgeon that they wanted to release back into these waterways because they felt that they had resolved some of the hindrances to normal migration and spawning.
Mm-hmm.
But they didn't want to release these high value fish in case they got it wrong and they all died again. So they wanted to actually release a low genetic value, a non-endangered species. But then the concern is that if everything works out fine, the fish you've just released can then breed,
right,
and pollute the gene pool. So they said, could you sterilize these sturgeon? They tried to sterilize these sturgeon using traditional surgery. And if you imagine, if you've got, say, a 3-foot sturgeon, its gonad, its testis or its ovary, is probably about 15 to 18 inches long.
Wow.
Right? It's a very long structure. Yeah, it's a very long structure, almost runs the entire length of the coelom internally. And so to get that out, you have to make such a big incision. You've got a 3-foot sturgeon, you're making an 18-inch incision. And fish do not tolerate large incisions because you're obviously putting them back into, even if you put them back into pristine water,
infection.
It's still a biological soup,
right,
or bacterial soup. And so they got about a 95% mortality rate when they tried to do it surgically. And so they came to us. And in fact, this was a project I did with Clarence Rawlings. So it was back in the mid 2000s. And we came up with an endoscopic technique, sort of a laparoscopic technique.
right.
And we went from 95% mortality to 95% survival.
Oh, that's awesome.
And it just flipped it completely around. And that was the reason I bring that up is that was the first reported multiple entry laparoscopic technique in any fish species. And so that was another first for the University of Georgia, which we were very proud about, but just goes to show you how you can really have a paradigm shift in some of these surgical procedures. If you can go to endoscopic. And actually, I can think of one other one, actually. This is not a research one. This is a clinical cases. But, birds. So if you imagine a bird, if you've ever dissected a bird or eaten a chicken, you've got that huge keel bone,
right?
That huge bone, which basically protects, the heart and the cranial structures. And it's almost impossible. If you've got something in there like a mass or a tumor or a granuloma, it's almost impossible to get to it. And we've had some gifted surgeons that have tried to temporarily remove the keel to operate and put the keel back. And every bird has died during the surgery. They've not been able to do it successfully. So we use this endoscopic technique with those 3mm laparoscopic instruments. And I got my resident and myself, and we were able to remove this granuloma from the heart base of a Geosaca falcon. It was a bird of prey that came to us from California.
Uh-huh.
And that bird made a complete recovery. Previously, that bird had an inoperable condition, and now it actually had an operable condition and made a recovery. And so I think these minimally invasive techniques are just so important, not just for humans, but so important for animals as well.
For the ecology too. I mean, it's amazing.
Absolutely, yeah.
Last question for you, and it's relative but not. So here in Austin, we have it's a river, but it's in Texas, so it's called a lake because they dam them up. So, we always have everything bigger here. But there's a lake, a lot of these lakes here, there's a different term for it, but they call it duckweed. It was overgrowing these lakes, and it was brought in from a fishing boat into these lakes. So they had a big problem with it. So they introduced sterile Chinese carp because they're really invasive to eat them all. Is that the same thing that they're doing? Is that how they make them sterile? Have you heard that before? Sterile Chinese carp?
Yeah, well, so I've heard that. I mean, we have huge issues with Asian carp,
right?
Breeding, and so I don't know whether they were sterile or they thought they were sterile and they weren't. Like the whole Jurassic Park situation where nature finds a way. I don't know. I'm not familiar. I do know that these Asian carp have basically spread throughout many of the waterways of the United States, and there's huge concern about them getting into the Great Lakes. And I think this is the same species that you'll see these boats, and as they go across the lake, these fish are jumping out the water and actually potentially a traumatic hazard for people.
Oh, they're big.
Yeah, they get big. I don't know. There are mechanisms by which you can hybridize the genome and you can sterilize them. I don't know how effective that is, or whether they've come up with a system by which they can sterilize them, because previously they weren't sterilized and they've been breeding profusely. So I don't know how effective that will be, because it seems like the horse has already bolted out of that stable.
Well, I think it worked. I mean, this is several years ago they introduced them, and now you don't really see the duckweed anymore. And I don't know if they reintroduce them all the time. I haven't really followed that much, but it just meant when we're talking about sterilizing fish, I just wondered if that was part of what some of the things, what they're using, your technique or whatever it is. It's just out of curiosity.
Well, if they were taking out weed, was it actually the Asian carp, or was it sterilized like grass carp?
Well, they called it China. I think it was called Chinese carp. I remember it was a big thing in the news. At that time, I happened to live on the lake, and it was horrible. I mean, by the end of the summer, because get so hot here, the entire lake was just this grass farm.
You're right. You know what? I think you're right. I think they are of Asian origin, and I think you're right. They've been sterilized.
Yeah, it's just a wild thing.
It does worry me, though, that we have one ecological issue, and then we try and correct it by
Right.
using another biological control method. And if it works out, it's okay, it's great. But history is replete with examples of where we have introduced animals to disastrous consequences. So I trust people more intelligent than me are looking at those situations and making those decisions.
Well, generally, when there's an ecological or environmental problem, it was caused by the humans, not by the animals. Generally, that's the case. Look at the wolves of Yellowstone that they took away and they had to reintroduce them. Now everything's way better now again, too. It's the same old thing.
Yeah.
It's the same story repeated itself in different forms.
It is.
Okay, so we're at the end. I promise you I would do this under the window. So as I mentioned to you, I always tell a silly animal joke. And for you guys listening, I know you're cringing already. Here's my joke of the day, and it's a little bit relative to what we're talking about today. So here's my joke, and just grin and bear it, Stephen.
Okay.
What kind of a fish works in a hospital?
Hang on. What kind of fish works in a hospital?
Uh-huh.
God, I don't know, but I know it's going to make me cringe. Go on, tell me.
Here we go. A sturgeon.
In fact, you know what? I should have got that, because they did a story. They did a story on this sturgeon surgery that we did. And the byline was sturgeon surgeons at UGA or something. So I should have got that. I feel terrible that I didn't catch on to that.
Well, when we're done and we're off air, I'm going to tell you a rugby sturgeon thing here in a second. But anyways, for everybody that's listening, first off, obviously I need somebody to tell better jokes. You can, if you email me and you want your grandkids, your kids, your nieces, nephews, I promise you I'll get back to, or if you want to be on the show, just email me at mkyleforrealpodcast.com. Also, if you got ideas like this, I love interesting subjects. And if you can do that, also email me. If people have questions for you, Stephen, is there a way to contact you? I mean, I can put it in the description of the thing. I know you've got so many papers out there and all that kind of stuff. So
yeah, I think based upon what we've been talking about, I think people can find out the information just by doing like a Google Scholar search or something like that. It's very tough for me to respond to individuals. And so rather than suggesting that and then letting people down, it's probably best that they look on the Google Scholar for some of those papers. There's plenty out there.
Okay. And by the way, you guys, if you want to email me, I'm happy to do a little research and send you information, because obviously I did some on this thing and I can get back to you. Stephen, first off, thank you so much for being on the show. It's been a blast. I didn't know what direction we were going to go, and it was even better than I thought it was going to be. So thank you so much.
It was my pleasure. And to be honest, if we did it again, it will be completely different, because I get the impression that, there was no rhyme or reason to this. We were just meandering around.
Yeah.
So this was a unique podcast for sure.
You know what, then? You're stuck, because I'm going to reach out to you again. Yeah, that was a bad statement on your part.
Right.
But anyways, for everybody else out there listening, really keep listening, pass the word on. But most importantly, thank you so much for listening from the bottom of my heart For real.
That concludes this episode of For Real with your host, Mark Kyle. For previous and future episodes of For Real, listen via all major podcast streaming sites.